So what I want everybody to do now is remember all the facts we just said about base 10. Because what we're going to do now is change the base, but take the same rules. You with me? You ready? Okay. So let's take a binary number, which is the first base we're going to look at. What type of values can the computer store? I forget. What were the values the computer can store? Okay, the computer can store 0 and 1. So what base does that mean is going to work in this situation? Base 2. And that means that, what is base 2? What numbering system is base 2? Binary. Okay? So let's count in binary. You ready? Let's count in binary. Okay? First comes, then comes 1. Okay, why? You're correct, but why 1, 0? Why is 1, 0 next? I'm out of digits, so I have to go over to the next placeholder. Give them a minute. Give them a minute to think about this, okay? So it's 0, 1, 1, 0, 1, 1. We're out of digits, so now we do what? Over to the next placeholder, okay? Do you know what comes next? 1, 0, 1. We're starting over in the ones column. Okay? Now we're out of digits here, so we're going to go to 1, 1, 0. The next one's easy, I think. Okay? And then we're out of digits, so we have to go over to the next. Okay, what do you think comes next? 1, 0, 0, 1. 1, 0, 1, 0. 1, 0, 1, 1. I'm going to move this so that the can show up in the camera. 1, 1, 0, 0. 1, 1, 0, 1. 1, 1, 1, 0. And then what's 16 going to be? 1 and okay. Binary values from 0 through 16. Okay? Sort of, kind of? So now, let's talk about how we're going to go from binary to decimal. So if I put up this number right here, it looks like a binary number, but the way to be sure that it's a binary number is to put a 2 as a subscript right here. That indicates it's a base 2 number. Does that make sense? Does that make sense? So now, this time, the value here is 0, and what am I going to multiply this time? What base is this? And which guy is this? What did we do when we did tens? I hear a lot of bumbling. 2 to the 0, which is 1. Okay? That equals 0. Let's carry down. The 1 is the digit. We're going to multiply that times what? 2 to the 1, which is 2. So what's the answer here? This guy is a 0. What are we going to multiply this times? And but the bottom line is the answer is bring down the digit, which is 1. 2 to the what? 3rd, which is what's this one? Which is, we add this sucker up, 10 and 6, carry the 1, 26 base 10. Question? You did it just on top of the number? You're essentially doing the same thing. So if that works for you, that's okay? Okay, let's try one at our seats. Okay? Let's try doing, so I'm going to give you a binary number. I'm going to give you a binary value of not the same one. Okay, so go ahead. You can work with your partner on this. Try to figure this one out. So write the number down, and then go through the steps slowly. First time you see this, you know, it's funky. It looks like a foreign language. Convert this number to decimal. Everybody try it. Convert this number to decimal. He told me to restart the computer, so I guess we did that. Okay. Okay, so how are we doing? How are we doing? So you make sure now, start at the right, draw your, this is sort of like a bookkeeping thing. Start at the right, go down, draw your digit down, take your value down, compare answers with your neighbor, see if you got it right. Okay? Okay, take your next value down. So you're doing a different way, or?
No, I'm just not writing it out.
Okay. Okay, everybody's getting, is that what everybody's getting? 30? 46. Oh, I'm looking at the wrong one. Okay, 46. Yeah, everybody get 46 and see why? You getting 46? Okay. Get it? No, what don't you get? 0 times 2 is 0 is 0. 1 times 2 to the 1 is 2. 1 times 2 to 2 is 4. 1 times 2 to the 3 is 8. You're doing it right. 1 times 2 to the 5 is 16 times 2 is 32. Yeah. Okay, we're doing okay? Let me know if you need help. You doing okay? Looks like you're okay. Try this. Do not be afraid. Okay, 46. Good. Good. Okay, what did you miss?
I got the wrong number.
Oh, okay, there. That'll do it too. Okay, so let me go over this one. We'll try another one. So the way to do this is 0 times 2 to the 0 is 0. 1 times 2 to the 1 is 2. 1 times 2 squared is 4. 1 times 2 to the 3rd is 8. 0 times 2 to the 4th is 0. And 1 times 2 to the 5th is 32. So you add that all up and you get 46. Okay with that? Okay? Okay, so let's now move to the alternate. We're going to practice. We're going to have lots of practice. Okay? Let's move to the alternate conversion, which this is the hardest one we're going to do out of all the conversions. And this is going to be decimal to binary. Now remember, if we went from binary to decimal by multiplying by 2, right? Went from binary to decimal by multiplying by powers of 2. How do you think we're going to go from decimal to binary? Divide by 2. Okay, now this is the hardest. It's not hard math. It's just funky. That's not hard math. It's just funky. So the first example we have here is 19. Let me show you how you do this. So if I have decimal number 19, and I want to find out the binary value, what I'm going to do is I'm going to draw this like kind of old-fashioned divide. Divide by 2. Put the answer down here. So 2 into 19 goes how many times? 9. And what I'm going to do is I care about the remainder. I'm going to write the remainder out to the right-hand side. Okay? And then I'm going to repeat the process. So 2 into 19 goes 9 times, which is 18. I had 1 left over. Let's repeat this. 9 divided by 2 goes how many times? 4. And the remainder is, okay? 4 divided by 2 is 2. Remainder is 2 divided by 2 is, remainder is, you're not done yet. This is where people get screwed up. They get at the end and they like panic. No panic. Okay? So 1 divided by 2 goes, how many times does 2 go into 1? 0. And the remainder is, and the answer is backwards this way. Can you guys see in the back corner there? The answer is backwards this way, 1, 0, 0, 1, 1, which is the same thing that's on the board here. It's the binary equivalent of 19. You read it backwards. Backwards. So 1, 0, 0, 1, 1 is 19. Well, the 2 just says that's the base. You want to try one? Questions so far? Now, this is just tedious. It's not hard math. We all know how to divide by 2. It's just kind of a bookkeeping thing that you have to kind of keep straight. The problem is if you make one mistake, then your answer is wrong. I'm going to show you how to check your work, okay? But first, let's learn the method. All right, so let's try, at your seats, converting 23. Let's convert 23 to binary. Let's convert 23 to binary. Raise your hand if you need help. You're not sure how to get started. Okay, good. So now what's the right? Okay, good. I think you missed one, though. No, it's not 10. It's going to be what? 11. Right. Okay, good. So then the answer is, right. How we doing? Okay. Okay. Okay, you guys are making this look easy. What? Okay, so take 20, write 23, and then kind of put, divide by, see how over there, divide by 2, but kind of the old-fashioned kind of divide? Yeah, okay. Now put the answer down here. What's 2 into 23 goes how many times?
12, or no, 1, 2, yeah, 12.
Too many, 11.
But 1, sorry, yeah.
And then there's a remainder, and that's 1, put that over here. Okay, so now do the same thing. Take the 11 divided by 2. So go through the same.
Oh, okay.
Okay, all right, yeah. All right, okay. Now don't forget your remainder. Why am I so scratchy.
Right here.
The remainder is going to go out to the right. This is the funky one. See how the remainder's out to the right?
Yeah.
Yeah, so if 2 into 23 and 11, put the 1 right over here. Save your remainder, okay? 2 goes into 7. Where am I getting 7? 2 goes into 11. How many times?
5.
Right. How many were left over? Right in here. Okay? Try the same thing. Okay? This is the hardest thing we're going to do. 2 goes into 11. 2 goes 23. It's hard for me to look at the middle. I'm just redoing it. 2 goes into 23, 11 with 1 remainder. 2 goes into 11, 5, 1 remainder. 2 goes into 5 twice, not 4. 2 goes into 5 2 times. Right? 2 goes into 5 2 times. Right, 2. And there's a remainder of 1. Oh, yeah. 2 goes into 2 how many times? 1. Okay, 0 remainder. Okay, 2 goes into 1 how many times? 0. And there's a remainder of 1. If you could try to take a 2 into 1 and it goes 0 times, there's still that 1 left. No, let me do it. Okay, you were almost there. The bottom is the tricky part. The bottom is the tricky part. You kind of want to be done and you're not. Okay, so let's, 2 into 23 goes 11 times, the remainder is 1. 2 into 11 fits 5 times, the remainder is 1. 2 into 5 goes 2 times, the remainder is 1. Here's where it starts to get tricky. Not tricky, but just you kind of feel like you might be done and you're not done. It's hard to finish this problem. 2 into 2 we know goes once and there's no remainder. We're not done yet. Okay, keep going. So now we're going to take 2 into 1. 2 does not fit into 1, but there's a remainder of 1 because the 1's still sitting there. Okay, so 2 into 1 goes 0 times, remainder 1. So the answer now is 1, 0, 1, 1, 1. You with me? Okay. Now, this is kind of a pain. And imagine for very large numbers that this would be ridiculous to do. So I'm going to show you how to check your work. Let's find it on this sucker. Question? Where? 2 goes into 2 once. Two goes into 2 once, remainder 0. 2 goes into 19 9 times, remainder 1. 2 goes into, no? Oh, did I write the wrong answer on the board? It's a different problem. Okay, where do I have that? 2. I think I'm just writing the answer at the wrong place.
No, that's 4 and that's 5.
2 into 11 goes 5 times, remainder 1. Remainder 1. 2 into 5 goes, this is the guy for this one. This is the guy for this one. This is the guy for this one. This is the guy. 2 goes into 5 2 times, remainder 1. Okay? I know, it's crazy. Okay, so let's look how, we'll practice. This is the only hard, tricky one. Okay, so I want to show you how to check your work. So in this particular case, we had, first of all, you have to make sure, if you bring up the calculator, you typically have, can everybody see this? You typically have the standard calculator on on Windows. And if you click View, guess what? There's a programmer calculator. That's what we are. We're programmers. Okay, so you select the programmer calculator. You type in the decimal number, 19, and then you want to find the binary, and it hopefully gives us the same answer that we had on the slide, which it is, okay? And that's just a way to check your work. So, of course, you should check your work.